This is the case of left hand limit. We find left hand limit for root over x minus 5 does not exist. Here I have given the definition or value of modulus of x. When x is negative, value will be minus x. When x is 0, value will be 0. And when x is positive, value will be x. And for x positive, value of fx is this one, and already we have calculated value will be finally 1 for fx. Welcome to btosacademy. Welcome to my maths class. After puja, this is my first class. Therefore, Shubho Vijaya to all my viewers, all my students, all my followers who follow my class. Now, I am going to discuss, already I have written on the board, limits, remaining part. Then I shall start differentiation. First of all, about limit. Let me write down few sums. Those are based on conceptual matter, also analytical. I shall take one by one sums and discuss. Does the limit x tends to 5 root over x minus 5 exist? Already we have discussed x tends to 5 means x takes values which are near to 5. Those may be less than 5 as well as greater than 5, but never x equal to 5. We consider two cases. When x tends to 5 minus, we take values like this. You know, each of these values are less than, a bit less than, slightly less than 5, but near to 5. Then let us calculate x minus 5. X minus 5, 4.99 minus 5. That is negative. When x equal to 4.99. Similarly, if we calculate x minus 5 for these values also separately, we shall see x minus 5 will be less than 0. Therefore, root over x minus 5 does not exist. Actually, root over negative number, that is not defined. In case of real number, that is not defined. Therefore, root over x minus 5 does not exist. Therefore, limit x tends to 5 minus this is the case of left hand limit. We find left hand limit for root over x minus 5 does not exist. Therefore, L if 5 where fx equal to and what is the condition of existence of limit as x tends to a of fx is LFA must be equal to RFA. Both are finite, of course. We find that LF5 does not exist. Therefore, we conclude limit x tends to 5 root over now one thing I have calculated here first left hand limit as x tends to 5 and we find that does not exist. Hence, we need not discuss about x tends to 5 plus. Therefore, if you find that any of the two values LFA RFA does not exist, you need not discuss the other. Therefore, the problem is solved. Next, I have taken two sums. Fx is defined like this. When x tends x less than equal to 1, then fx equal to 2x. When x greater than 1, fx equal to 3 minus x. We have to discuss about the existence of the limit, this one. When x less than 1, limit x tends to 1 minus fx. This is also L f1 is equal to limit x tends to 1 minus x tends to 1 means x is slightly less than 1, bit less than 1. For that, as per definition, you see when x is less than equal to 1, value of fx is 2x. Therefore, in place of fx, we have to write here 2x. Now 2 is constant, that is taken outside. X tends to 1 minus x 2 into 1. Finally, we are putting x equal to 1. Then after simplification, the value is 2. When x greater than 1, R f1, that is limit x tends to 1 plus fx. That means for x greater than 1, value of fx we find 3 minus x. We substitute that here. and this can be written as limit x tends to 1 plus 3 minus limit x tends to 1 plus x. Then this is limit on a constant as per theorem we have discussed, that is equal to 3, and for this 1 we can write this step earlier than this and we get 2. Then what we have got, left hand limit and right hand limit both are finite and equal. Therefore, I write here, therefore L F1 is equal to R F1, which implies limit x tends to 1 fx is equal to 2. Let me repeat, x tends to 1 minus, that means x is just less than 1, limit x tends to 1 minus fx. I have put the value, this one, as fx takes this value 2x when x is less than equal to 1. After calculation we have got value 2, and for x greater than 1, this is left hand limit and this is right hand limit. We have calculated and got the same value. Therefore, L F1, R F1 both are finite and equal. Therefore, as per the condition of existence of limit, we conclude that limit x tends to 1 fx exists and the value will be 2. This sum is finished. Now let us come to this problem. Fx equal to mod x by x. I think students, you have learned mod x. We read it as mod x, that is actually absolute value. As per definition, absolute value or modulus of x is its unsigned magnitude. Therefore, this will be minus x when x less than 0, 0, x equal to 0, x when, here I have given the definition or value of modulus of x. When x is negative, value will be minus x. When x is 0, value will be 0. And when x is positive, value will be x. Thus, I have defined here the absolute value or modulus x. Now, let us discuss this problem. When x is negative, fx will be, as per this definition, modulus x will be minus x by x. Therefore, value will be, here x is non-zero, therefore we can divide minus x by x, the value will be minus 1. When x is positive, fx is equal to x by x, that is 1. Therefore, L F0 limit x tends to 0 minus fx. Left hand limit LF0, that is equal to limit x tends to 0 minus fx, and this fx will be this one minus 1. Therefore, limit x tends to 0 minus value will be minus 1, and RF0 limit x tends to 0 plus fx, and for x positive value of fx is this one, and already we have calculated value will be finally 1 for fx. Limit x tends to 0 plus 1, value is 1. We find values are different, therefore LF0 is not equal to RF0. Though both the values are finite, but they are unequal. Therefore, limit x tends to 0, fx does not exist. Finally, we have got 2 LF0 value minus 1, RF0 value 1. That means values are different. Therefore, the conclusion is limit x tends to 0, fx does not exist.